To simplify these radicals, we will use the quotient rule. We are looking at the root of a quotient. Well, that is equal to the quotient of the roots. So in each of these cases, we can re-express the root of a quotient as the quotient of the roots. This is a root of a quotient. Now we'll make it a quotient of the roots. And from here, you can just simplify as normal. These are both perfect squares, so the square root of 25 is 5. The square root of 16 is 4, so 5/4 is the square root of 25/16. Okay? To check that, whenever we simplify a radical, we could always raise what we simplify it as, what our answer is. We could raise that to the power of the index. So 5 squared would be 25, 4 squared would be 16. This should be the number that was under the radicand, and it is, so we know that 5/4 is correct. So same thing here, 99/4. Now we'll simplify both of these. 99 is not a perfect square, but it is the square root of 9 times 11, which simplifies into the square root of 9 times the square root of 11. The square root of 4 is just 2. So that stays in here. The square root of 9 is 3. So this really becomes 3 radical 11 divided by 2. Right, we'll look at that one again. We were looking at the square root, so we were looking for numbers that have perfect square factors. We broke the 99/4 up into the square root of 99 over the square root of 4. The square root of 4, the denominator is 2. That held all the way through. The square root of 99, we looked for perfect square factors. 99 is 9 times 11. 9 is a perfect square, so the square root of 9 is 3. The square root of 11 can't be simplified, so we just leave it as the square root of 11. So all told, we have 3 times the square root of 11 over 2. All right, next thing over here. If we wanted to check this, by the way, we could take 3 radical 11 over 2 and raise it to the power of the index, and it should equal what's underneath here. So if we take 3 squared, that's going to be 9. 11, square root of 11 squared would be 11, so that's 9 times 11, or 99. And 2 squared would be 4, so that would equal 99/4, which was the original radicand, so we know that we have simplified this correctly. Same thing here, we had a quotient of, or we had a root of a quotient. We expressed it as a quotient of the roots. So now we're looking for perfect square factors of 125 and 144. 125, I know it has a 25 in it, so this is really the square root of 25 times 5. The square root of 144 is 12. It's a perfect square. So now the square root of 25 is 5. The square root of 5 is still itself. So 5 radical 5 divided by 12. If I wanted to check and see if this was right, I could take the whole thing and raise it to the power of the index, which was a 2. So 5 radical 5 squared, well, 5 squared is 25. The square root of 5 squared would be 5, so that would be 25 times 5, or 125. 12 squared is 144, and that would hold. So 125 over 144, that was my original radicand, so I know that I have simplified this correctly.